that one. What rule are we doing here? Another product rule. E to the x sine x. Derivative of sine x? Cosine x. Be careful between derivatives and antiderivatives, because on the antiderivatives, the negative sign switches. The antiderivative of sine is negative cosine, but for derivatives, sine goes positive cosine. Just be careful of that on the exams. Really easy to make that mistake. Okay, so we're going to get e to the x sine x plus e to the x cosine x. Okay, h. Go ahead and do that. So what rule are we using here? It's a chain rule.
Chain.
Okay, so we're going to get one over all the junk. So natural log is 1 over. Normally it'd be 1 over x, but we have junk inside there, so it's 1 over junk times derivative of the junk, which is 2x.
I had a part of it already.
Okay. Okay, I. Y equals 1 minus secant x over tangent x. What are we doing here?
Quotient.
Quotient rule. So 1 minus secant x tangent x. Okay, derivative of 1 minus secant x.
Negative.
Negative secant x tangent
Negative secant x tangent x.
secant square.
And tangent x is secant squared. And with this,
How did we get the first derivative? Negative.
derivative of 1 is 0.
Yes.
Secant x, just looking over there for secant x, is secant x tangent x.
And you just keep this the negative. Just keep this the negative. You have to have the negative.
Oh, okay. I made a mistake. Thank you.
Okay. And then, so now we're gonna get negative secant x tangent x times tangent x. We're doing quotient rule, so this is minus 1 minus secant x secant squared x all over squared x.
Will you take points for getting the y prime and fx prime?
No, I just did, it's fun. Okay, and J,
Would it be wrong if you did tan x to the second?
tangent squared, no, that's fine. That's a better way of writing it, but you don't need to do that. Okay, go ahead and do this one. Okay, so another quotient rule. Derivative of natural log of x. X, derivative here. Minus 1 over x. Prime of x is going to equal 1 over x, x minus natural log of x, minus natural log of x, 1 minus 1 over x, all over
X.
Any questions here? L here, this is the H that's in this secant and tangent here, that's referring to hyperbolic trig functions. We didn't talk about those were 311. I skipped over them this semester because we were running out of time. We were behind schedule. It's just another type of function. And it's not even really a new type of function. When that H is in there, the hyperbolic cosine is just defined to be this function. It's just that this function shows up often enough in applications that they just decided to give it a name. And the reason why they gave it the same names as the trig functions is because they have a lot of the same properties of trig functions. So cosine squared plus sine squared equals 1. With the hyperbolic trig functions, it's cosh is how this would be pronounced. Cosh squared minus hyperbolic sine squared equals 1. Instead of plus, it's a minus. It's a lot of the same trig formulas, except they're some of the signs get mixed up there. And when we take derivatives, the derivative of hyperbolic cosine is hyperbolic sine, derivative of hyperbolic sine is hyperbolic cosine. They just go back and forth directly instead of with the negative signs.
Is it gonna be on the exam?
No, not gonna be on the exam. We didn't talk about it this semester. It sometimes might show up. So in a later class, if you see one of the trig functions that has an extra h after it, that just means it's the hyperbolic trig functions instead of the regular trig functions. But we're not gonna do anything with it. We didn't cover it, and it's not gonna. Okay. So now we're gonna skip over all of this other stuff in the middle and just go straight to problem 19 with integrals. Some of them will have limits of integration, some of them won't. What's the difference? If we do have limits of integration, what do we do? Antiderivative, then plug them in. If we do not have limits of integration, what do we do?
Nothing.
We take the antiderivative, what do we have to put at the end? Plus c. Okay, so with limits of integration, we plug them in. Without limits of integration, we just do a plus c. Okay? So, you guys okay to do these on your own, or
Together.
do them together? Okay. From 3 to 5, 4x cubed.
Do you mean 4 to 6?
6. Minus 5x squared plus 2. Yes. Okay, so go ahead and do this one. What do we do with polynomials? What's the rule? How do we integrate those?
So, fucking clowns. No, I'm off on me. Two. I don't have my calculator.
Okay, so what are we gonna do? What does 4x cubed become?
That's right. Yeah, I forgot two. What am I thinking? 2x squared.
So add 1 to the exponent and divide by the new exponent.
I already forgot. There's a lot of information all
Yeah.
mixed up.
Minus 5x cubed.
Add 1 to the exponent, divide by the new exponent, And when we have a constant for antiderivatives, which is here, it just picks up the variable. 2x. Now this one has limits of integration, so we're going to plug those in.
No C. No C. No C. No C. No, no C.
So when we have limits of integration, we don't need the plus c, because we can make it anything we want.
You're talking about the endpoints, right?
Yeah, so now the endpoints, yeah.
Those are the ones, the limits of integration.
Limits of integration is the term for them. Okay, so we're gonna get 6 to the 4th minus 5 times 6 cubed over 3 plus 2 times 6. Minus
That's right.
3 to the 4th minus 5 times 3 cubed over 3
Mm-hmm.
plus 2 times 3. I'm okay if you leave it like that, or you can plug it in the calculator and evaluate it. Pretty sure this one comes out to a whole number, but. Okay. Questions here? For the integrals, I'm going to add another category here. So we have definite integrals, indefinite integrals, U substitution. And then also we'll get some that simplify. And there's really two things that that we're going to be looking at here. Distributing. So like problem D here, we would need to distribute that before we do the rule. And the other is taking fractions and splitting them up. So you're gonna need to be able to deal with these as well. Okay. And then once you have them split up, then you can do some simplifying. Okay, and so B is going to be one that's like this here. You guys want to do that one together? You guys ready to do that on your own? We just need to split up the fraction and then simplify. You might want to change the square root of x to x to 1/2 when you're simplifying there. So go ahead, actually go ahead and do that one, and then we'll go through.
B. Yeah, I understand. Mhm.
split this up, and I changed the square root to x to the 1/2 because it's gonna make it easier for our simplifying. So what's gonna happen here, x over x to the 1/2? So where are the x's gonna be left over here, on top or bottom? On top. We have more x's on top than we do on the bottom. We have a full x on top, a half of x on the bottom. How much extra is on top? Okay, so this is going to be x to the 1/2 for that one. Can you guys keep it down a little bit up back there? What about this other one?
The x is gonna stay.
So how do we rewrite this one?
We write it as what if
X to what power?
negative half?
Negative 1/2, yeah. Okay. And now we just apply our polynomial rule. We add 1 to the exponent, divide by the new exponent. Even if they're fractions, it still works the same. So 1/2 plus 1 is 3/2.
Why did only one of them change? So what happened in the first step?
Here, so
Yeah.
going from here to here.
Yes,
That's just splitting it up
okay,
into 2, and I changed the square root into x to 1/2 because that's gonna make the next step easier.
okay.
And then here, we're just subtracting exponents. 1 minus 1/2,
Right?
and here this is, because this is in the denominator, that's negative 1/2.
They both are in the denominator.
But this one has some in the numerator too.
Oh, I see.
Do you know, like, we have 0, like 0 minus.
Yeah, it's
1.
0, there's no x's up there, so 0x minus 1/2 an x. This is 1x, one exponent here,
Uh-huh.
Yeah,
minus 1/2 of
yeah.
exponent.
There's no F on the other one's considered 0.
0, yeah, 0 exponent minus 1/2 exponent. Okay, so this is gonna be, add 1 to that, we get 3/2, x to the 3/2, divide by 3/2, minus, now here we have negative 1/2 plus 1, which is positive 1/2. And this is going to be from 1 to 4. What can we do with this 3/2 in the denominator here?
We multiply by the reciprocal.
So we can flip it up to the numerator, but it flips upside down when it does that. So this is gonna be 2/3, 4 to the 3/2, minus 2 over 1, 4 to the 1/2. So I plugged in 4 into both of them. Same time I flip that up to the top. You can leave the 3/2 and the 1/2 in the denominator if you want to.
So there we have the denominator with the 0.
Where's the 4 coming from?
The 4's coming from here.
Oh, I see.
Minus 2/3, 1 to the 3/2, minus 2 over 1 times 1 to the 1/2. Okay. Any questions there?
So the exponent is coming down, right? 2 over 3 times 4. At this point, you're just plugging in.
In the endpoints, yeah. Right. C. Integral from 1 to 3, 1 over 2x dx. this is a very special case. And when you have extra numbers floating around like that, extra coefficients, sometimes it can be easier just to move them out of this outside, and it makes it a little bit clearer what's gonna happen next. So, now that we have it like this, so I just moved this 2 on the outside, now it's still in the denominator. I just moved it outside the integral, so I don't have to worry about it. It's gonna stay, but it's not gonna affect anything. This is 1 over x is gonna be, the important part here.
I know we've been doing this, but I'm just a little confused. Well, what is going on with 1 over 2? Or why are we dealing with it?
It's a coefficient.
Yeah.
Coefficients just stick around. They just cling to the variable and hold on to it wherever it goes. So, same thing when we had derivatives. If we had, say, 3e to the x, and we took the derivative, what happens to the 3? Nothing, just stays.
Same.
It just stays. Same thing here. The 2 is just going to, the problem is just gonna be a 2.
You're just taking it out so you don't have to deal with it?
I just taken it out so I don't have to deal with it. Because now this matches one of our formulas over there. So what does 1 over x become?